These are valuable functions where you only have to look at the initial and the final state. You don't have to look at the path at which you travel. So state functions. Properties determined by the initial and the final state. Of a system. And not the intermediate states, the points in between. Okay. On the back, I wrote finish, the finish line. Right here is the start. I need a volunteer, someone who's willing to run and move. Anyone, before I selectively pick somebody. Anybody at all. Could be anybody in the room. Could be, hey Gio, come on up. All right. So the way this is going to work, you can kick off your samples too if you feel better about that. We're doing good with them. That works too. Okay. If you beat me before I get there, you get 2 bonus points on your next exam. Sound good?
Just running?
Yeah, we're just running. We start here. Our hands have to go up here, and we're going to run to that point. Okay. All right. We need someone to say go for us, I guess. Okay, who wants to be the announcer to give us the... Olivia, you're in. Okay. You're going to tell us when to go. You're the sports. There's a little desk back there. It has finished written on it. Okay? You ready?
3, 2, 1, go.
Okay. You won. Now, who spent more energy getting to this point? Did Gio or did I? Or, excuse me, who did more work? Why me? Yeah, I went around. I took a weird path, right? How about our displacement? Was our displacement, we'll call this the y direction, was our displacement in the y direction really different? No, not really. We ended up at the same point, right? So our displacement, our change in y, or I don't know, we'll say Simpson and Gio was equivalent to one another. But what about the work that we did? Who did more work? Yeah, I didn't win, but I did more work. I expended more energy. Displacement is an example of a state function. It only depends on the initial and the final. Work is considered something called a path function. It depends on the points where you move. So this is a path function. Okay, and that's a very important point because in thermodynamics, some properties are state functions, some properties are path-dependent functions. Most of the ones we'll deal with in this class are state functions. So as an example, could you give me another example of a state function where it only depends on the initial and the final state? Yeah, temperature. Give me another one. We're thinking about ideal gases. Volume. What else? Yep. Yeah. And that's why the ideal gas law is very valuable in a way, because all of the properties that we're talking about, they're all state functions, which is nice. We can look at before a reaction, after a reaction, measure some stuff, we're good to go. We don't have to monitor the entire reaction as it progresses. Okay, everybody feel like they have an idea of what a state function